Okay, so now in 5.7, so this is outcome R5, we're going to look at graphs of linear functions. So let's talk about what we have and what we're looking at when we are analyzing these graphs. So the first question says this graph shows the height of a burning candle that changes with time. What happens to a candle when it's lit? What happens to the height of that candle? It decreases, it starts to diminish, it goes down, right? It melts. So eventually, what happens to this candle of ours? So so let's look at this graph right here. And what do we notice about the height of the candle when we start our time? When we first light it, it is a height of 10 centimeters. Okay, so this is 10 centimeters. All right, so that's 10 centimeters at the top there. And now how long does this candle of ours burn for?
45.
It burns for 45 minutes. So how do we figure that out? Where do we see that information? Right there? That's 45 minutes. Okay. Now, what are the coordinates of the graph, or of the points where the graph intersects the axes? So what are the axes? So I've got two axes, which are called the vertical one. This one going up and down here is my height. This is my vertical axis. And then this over here going across in the horizon is the horizontal axis. So what is the coordinate of this point right here? So the x value is 0. And what's the y value? 10. So, and make sure when you're drawing coordinates is that you have your x and y values. This is a 10. Okay, so my x value is 0, and my y value is 10. When you're writing coordinates, you have to remember to have brackets on either sides and a comma in the middle, right? Okay, so for this here, what's the other point that intersects the axis?
45.
So my x value is 45, and then my y value is 0. All right. Okay, so let's separate these two and let's determine which one of these is the vertical intercept. So which is the vertical one? Vertical goes straight up and down, and it is 0, 10. All right, this is also known as my y-intercept, okay? My y-intercept, because that's where it intercepts with my y-axis. And the horizontal intercept is 45, 0. And make sure you have your brackets around it as well. So what do you think that one's also called? The x-intercept. Good. Okay. So if you were to describe in words what each of those points of intersection represents, what would you say? So the vertical intercept, let's call this VI. So let's call it VI. So what would we say VI is? So VI represents what in words? The height of the candle when? The height of the candle either just before it's lit or when it's first lit or when you start your timer, right? So how could we say all that nicely? The height of the candle first or right when we, at the beginning, when we light it? When it's just lit. When it's first lit. Okay, good. I like that. And then horizontal intercept. What am I going to call this one? Horizontal intercept. What is this in words? So that is way over here, right? Where it hits the horizon. So what's happening right at that point? When the candle, that's how long it takes the candle to burn out, disappear, melt away completely. It's when the candle reaches a height of, when the candle reaches a height of 0. Okay? All right. So the candle's gone. So now if we're looking at the domain and range of this function, what information am I looking at for the domain? The domain is talking about which variable here? The time. And so what is the maximum and the minimum for my numbers here? What values am I looking at? So my time here, my minimum here is 0. And what's my max? Okay. So 0 is my minimum. 45 is my maximum. And then I want to fill in the other information, right? So time is my variable here. And then time, well, 0 is less than or equal to time. And time, the greatest number for time is 45. So that's my domain. So how do I read this? Time is in between 0 and 45 inclusive of the two endpoints. All right. And let's look at the range. What is the range here? The range of this is, so the minimum value is 0. What's my maximum value? 10. What's my variable? H. And then fill in the inequalities so that my statement makes sense. So time is in between 0, height, boy, here, let me write this in words here. Height. Height of the candle is in between 0 and 10 inclusive of the endpoints. All right? Okay. So that's my range value. Okay, so number 2 is skipped here. I'm going to do those graphing questions tomorrow, all right, on a separate piece of paper. So that's why 2 is missing. All right, so now let's have a look at the question here where it says, which graph has a rate of change of -5 and a vertical intercept of 100? Okay. First of all, what do you notice about these two graphs? They both have a vertical intercept of 100. Okay? So the vertical intercept of 100 is right here. Whoops. All right. So that is right here and right here. But what's the deciding factor of telling us which graph matches that situation? A rate of change of -5. So the rate of change is negative, which means the line is going to appear to be going downhill. Which of these two graphs is going downhill? So this is going downhill, and this is going uphill. Okay? All right. So this has a rate of change of -5 and a vertical intercept of 100. This is going uphill, so it does not match our situation. All right. And now this last question we're going to look at, it talks about the cost of an electrician's house call. So let's first look at the graph and see if we can understand what it means. So what can you tell me is the vertical intercept of this graph? So this is at 0, 60. All right, so that's where the graph starts. That's where this electrician starts charging money. What time is it when she's made $60? 0. So basically that means she shows up at your door and boom, owes you owe her 60 bucks. Just for showing up.
Does that actually happen in real life?
Yep. They, like, let's say, well, just for showing up, it's like a, because you've spent the time to go there, right? Right. Well, and everyone's different, right? So here, $60 just for showing up, plus 60. Now, how much does this electrician make per hour? Can we figure that out using our graph? What would that be? How could I figure that out? I need to figure out the rate of change. So what is the rate of change? So I can look at, basically all I need to do is figure out how much I go up and over. I could go, let's see, why don't I look at it from this endpoint to this endpoint here. What's this number? What's this y value right there? 300. Why is it 300? Because I'm going up by how much each square? 60. So I count from 240 up 60 more. Okay. And so what is the difference between here and here? 240? Okay. And what about from here to here? How much time has passed? So 6 hours have passed, right? All right. So my rate of change is going to be 240 divided by 6. What does that equal? So $40. So that means she charges $40 per hour. Okay? So I need to write 40 here. Now, how do I indicate that I multiply the number of hours for every hour that she's worked? I have to write an X here, right? So that X represents the number of hours worked. Okay. And then if I wanted to write this in function notation, how would I write the first part? I would have f of x is equal to 40x plus 6. So now what does x represent in this one? X equals the number of hours worked, okay? Just so we have that, we know what our variable stands for. Now, if she charges $190 to complete a job, how many hours did she work for? Well, let's look at the graph and see if we can figure out what it would be graphically. So where do you think this is going to occur? If she makes $190, where are we on this? We look on our y-axis, and 190 is going to be, well, what's this here? 180, and then 190 is just going to be above that? Okay, so we're going to go over to our line until we hit our graph, and then I'm going to go down from there, and I'm going to get a number somewhere between 3 and 4. Can we estimate how, what do you think, like 3-ish hours? But ish isn't very exact, is it? It's not quite 3.5 though, is it?
3 hours and 15 minutes.
Okay, so you're thinking 3 hours and 15 minutes, or it's a little less than 3.5 hours, right? So let's figure it out exactly using solving this equation. So if I wanted to fill in a number for here, where would I fill in this number here? Where would the 190 go? Is that a range value or a domain value? It's a range value. So where would I substitute it in this equation? Right here, yeah, the f of x. So I'm going to say 190 is equal to 40x plus 60. And what am I going to solve for now? Solve for x. What's the first step in solving for x? Minus 60 on both sides. So what is the left-hand side now? 130 equals 40x. Divide both sides by 40. And x is equal to 13 over 4, or 3.25. Okay. And this is hours, right? So what would I write as my sentence? She worked for 3.25 hours. How else can I say that? I would say leave it as that, because it's an exact number, right? So 3.25 hours, I could also say. 3.25 hours. Make it make sense. 3.25 hours, or how else can I say it? 3 hours and 15 minutes. Okay? So either one of those are fine. So we can look at it graphically. We could also look at it as an equation and solve it like that. Okay, yeah, homework time, woohoo. So tomorrow we're going to do the graph, the question that was supposed to be number 2 in this. We're going to do that tomorrow, okay? So have a look at the equations and do that homework that's there.